In this video, we're going to be talking about systems of nonlinear equations. All right, so kind of graphically what that would look like is normally we would have a line that crosses another line. That's systems of linear equations. But nonlinear, you might have like a parabola or a circle, right? Or, another circle. They can be cut by a line or by another parabola or something like that. But we're going to try to find the intersection of where those things happen. So for example, this would have two solutions. This would also have two solutions. They don't always have two. The ones I drew up here, I guess, do. But sometimes they have one, sometimes they have more than one, two or three. And what that would look like is if we had an equation like this, this is an equation of a parabola, and then an equation of a line, I would know where those two things meet. And so we're going to try to do that algebraically. Let's try it. All right, in our first one here, we have two equations. We have x plus y equals 3. This just would be a line. That's a linear function. But this one, y equals x squared plus 1, this is going to be a parabola. And so if you think about kind of what could happen here, we would have, like a line. It could intersect the parabola and maybe 1 point, no points, or 2 points is probably the thing that could happen with this. And so I need to solve this very similarly to how I would solve a system of linear equations. But since this is nonlinear, our answer might just look a little bit different. And we know it's nonlinear because of the way the function is set up. This we know is a parabola. All right, so I would do a couple things here. One, I'm seeing that right away, just like when we solved systems of linear equations, we either had substitution or elimination. Okay, we're probably not going to solve this one by graphing because I don't have a graph readily available to me. But I think this would be easiest with substitution as my y is isolated. So just like what we did with linear equations, I'm going to take and put a box around what that y equals, and I'm going to substitute it in for y in my other equation, meaning I'm going to be only left with x's, and then I could solve what x is, plug it back in, and solve for y. So what I mean by that here, this is going to be now x, I'm rewriting this top one, plus I'm going to leave a space where I see the y equals 3, and in that space I'm going to put what was in this box, which is x squared plus 1. And you'll notice that there's no y's left. As long as you have one variable after you substitute, then you probably set that up correctly. All right, let's see if we can solve this here, solving for x. I have x, I'll get rid of these parentheses, plus x squared plus 1. I'm going to subtract the 3 over to the other side, and that'll be minus 3 equals 0. And I'm doing that because I'm seeing I have an x squared, an x, and then a couple constant terms, so I'm probably going to have to factor this. All right, if I put my x squared term first, and then a positive x, and then 1 minus 3 is a negative 2. That equals 0. All right, let's go ahead and factor this. Again, different teachers teach you how to factor differently. So the way I teach my students is a little graphic organizer. A times c is negative 2. My b term is 1. I need two numbers that multiply to be negative 2 and add to be 1, which of course is going to be 2 and a negative 1 here. All right, those are going to be my factors. So we got x plus 2 and x minus 1. It still equals 0. I'm going to set those equal to 0 and solve. So x plus 2 equals 0, x minus 1 equals 0. Here, I would just have x equals negative 2 if I subtract that over, and x equals a positive 1 if I add that over. So you'll notice that I have two x values. And with that, that means that if I sub it back in, I'm probably going to get two y values. In other words, this is going to cross, if I think of my different options here, remember we had no ways that it could cross. It could cross once or it could cross twice. It's probably going to be the one that crosses twice, as I'm going to plug that in and get two different y values. So let's plug it back into our original function here. I'm going to take this negative 2. I'm going to put it into the one with the box. And if I do that, I'm going to have y equals, and then I'm plugging in x. I'm going to leave a space, squared plus 1. And in that space, we're going to put our first x, which was negative 2. All right, negative 2 squared is 4. 4 plus 1 is 5. So we get y equals 5. So I plugged in x with a negative 2, and my output was 5. So negative 2, 5 is one possibility. Okay, the other one, if I do 1, that same equation, I'm just going to kind of erase that and put a 1 in there. So y equals 1 squared plus 1. Excuse me. That's going to be 1 plus 1, which is 2. So y equals 2. And so here I plugged in a 1 and my output was a 2. So I have 1 comma 2. So my two potential answers, let me grab a different marker here. We have 1, 2 and negative 2, 5. Now you do have to go back and check to see if those satisfy your originals up here in green. Let's do that. If I plug in x as negative 2 plus 5, negative 2 plus 5 is at 3. Yes, it is. And we already plugged it into the second one, so the second one should work, right? Negative 2 squared is 4. 4 plus 1 is 5, which does equal our y. Same thing for this one. Again, I'm going to plug into the top one here. 1 plus 2, x plus y. Does that equal 3? Yes, it does. So I think they both work for both of our problems. So I can put a little check mark to show that we checked those out. Let's try a little bit of a tougher one. All right, number 2 here is a little bit tougher because we have this big, long kind of polynomial looking thing with x's and y's, and then another linear function, x minus 2y equals 0. This top one is actually a parabola turned on its side because our y's are squared, right? When you have the x's squared and the y's aren't, then it's going to be a parabola that's either up or down. When the y's are squared, it's one that's either on its side, left, or right. Okay, so if you think about what could happen in this one, let's say I have that parabola. I guess I need my x-axis also. And then a line, so I have a parabola with a line. It could either not hit, and we'd have no solution. It could hit exactly once, right? Or it could hit twice. We could have 2 solutions. So we need to figure out what this one is going to be. Okay, let me get that erased for us. All right, so let's do the same thing as we did before. I'm going to look for maybe an easy way to substitute something in. And I think I might need to manipulate this a little bit to get the x by itself. And if I add the 2y to the other side, I could have x equals 2y. And so then I could substitute in 2y every time I see an x. So it's going to go in right there, I think is my only x. And I'm going to rewrite this one for us, leaving a space, and then I'll put that in. Okay, and then in that space is going to go my 2y. So I should only have y's left, and I do. So I'm going to solve for y, and then eventually I can plug it back into my one with the box, and that should give me my x value. All right, let's do that here. We have 2y squared minus 10y minus 2y plus 18 equals 0. And what do I have now? I have 2y squared minus 12y plus 18 equals 0. One thing that might be a good little tip for you is as you do this, if you see like these are all even or all divisible by 3, go ahead and actually do the division. I'll make those numbers smaller, and I always find those are a little bit easier when you divide. It is okay to do this because we're doing it to both sides of our equal sign. All right, because I'm dividing this 0, still going to be 0 when you divide by anything. So that's going to be good. But this is going to leave you with y squared minus 6y plus 9. And that might be a little bit easier to factor than the original. All right, let's see here. This is going to be, if I factor this out, y minus 3 times y minus 3. Again, if you need to do that graphic organizer, feel free to do so, but just did that in my head. All right, so we get y minus 3. Since it's the same thing, I'm just going to set it equal to 0 once and solve. Y minus 3 equals 0, add 3 to the other side, and we get y equals positive 3. Okay, I'm going to plug that back in to my x over here. You can probably just in your head, 2 times 3 is going to be 6. So x is going to be 6. Now, if I want to put that together as an ordered pair, it's going to be the point 6, 3. Which means this is going to only hit once. That line kind of with that parabola is just going to hit once when they touch each other. And so therefore, that is my only solution for that. Now, if you want, you can plug it back into the original and see if it works or not. But I think I might let you do that on your own. All right, let's try one more that's going to be really tough. All right, this last one we're going to do I think is the toughest because this is a circle. When you have x squared and y squared, if they're both squared, you're going to have a circle there. And then the other one's going to be a parabola. So we don't have a line this time that's intersecting. These are both going to be nonlinear, a circle and a parabola. So let's think really quick the different types of possibilities we could have for those intersections, how many points there would be. First off, I have a circle. The parabola could either be all the way above it or it could be on the inside of it. And so it could be 0 points that intersects. Let's see. I might leave that up here for us. So 0 possibilities. It could be exactly once if like it was right on top, or maybe it hit the very bottom of it. So 0, 1. Could I get 2? Yes. I think if it maybe touched the sides like that. So 0, 1, 2. What about 3? What if it started at the bottom and it went up through it like this? So 3. And then 4. If it was even below further, up like that. However, I don't think that I can get 5. So we have sort of 1, 2, 3, 4, 5, 0, 1, 2, 3, and 4 possibilities there of how many points could intersect. And so that's what we need to determine. And I'll tell you, this one right now is more than 2, like we've been getting in some of our last few problems. So let's try this. This one sets up very nice for that substitution method again, where our y is already isolated in the parabola one. So I'm going to take and substitute that in for the y in the first equation. And this now is going to be x squared plus, leave a space for the y squared, equals 9. And in that space, I'm going to put what my y equals, which is x squared minus 3. Right now, x squared minus 3 squared. Remember, this squared, I have to write that out twice and square it. Do the foiling here. X squared minus 3 times x squared minus 3. So first we have x to the 4th. Outer is going to be negative 3x squared. Inner is negative 3x squared. And last is plus 9. The 2 in the middle can combine to be x to the 4th minus 6x squared plus 9. And so that's what I'm going to put in instead. I'm going to say x squared, and then instead of this chunk, I'm going to rewrite it with this. Plus x to the 4th minus 6x squared plus 9. Now, I still have this equals 9. This is a different 9 from over there. So equals 9. And if I were to subtract this over, minus 9, both of those are going to cancel, which is kind of nice. And so I'm just left with some x squareds and x to the 4th. If I put the x to the 4th first, I like to usually write this in descending order for my exponents. This would be now 1x squared minus 6x squared, which is negative 5x squared. And because those cancel, this equals 0. So when I do the factoring here, I can just factor out a common factor. I don't have a trinomial anymore. I just have 2 terms. So I'm going to take out some x's, take out x squared actually, leaving me with x squared minus 5, and that equals 0. So I have 2 parts, x squared equals 0, and x squared minus 5 equals 0 that I need to solve for. If I do x, let me do it down here. I think I'm going to need some space later. If I do x squared equals 0, well, if I take the square root of both sides, I'm just going to have x, and the square root of 0 is 0. Even if you do plus or minus 0, it's still 0. So it's really just one solution there. And the other one, x squared minus 5, oops, I almost got ahead of myself there. Minus 5 equals 0 because I want to add that to the other side. And then it would be x squared equals 5. Take the square root of both sides here. Now you're going to have x equals, and you do need to have the plus or minus. And you're going to have plus or minus the square root of 5. So this is going to be 1, and then the positive 5 and negative 5 are 2 more. So 1, 2, 3 solutions. So I think it's going to look like that option. But we need to find the y's. These are all the x's, so I need to plug it back into this one of the box and figure out what our y's are going to be. All right, if I plug in 0 for x, this would be y equals 0 squared minus 3. 0 squared is still 0. Minus 3 is just minus 3. So y equals a negative 3 in that case. Remember, we plugged in 0. So my point here is going to be 0 comma negative 3. All right, that's going to be my first one. The second one, whether I plug in positive or negative square root of 5, when I square that, that's going to cancel my square root. So I think I can just do it once and get both of those answers. I'll show you what I mean here. Again, whether you do a positive or a negative square root of 5, since this is squared, right, I'm plugging that in for x and squaring it, minus 3. Those are going to cancel the square root and the square, leaving you with just y equals 5 minus 3. And in either case, the positive or the negative case, you're going to end up with 2. So y equals 2. So here, whether I have positive square root of 5, comma 2, that's going to be 1 point, so I'm not going to put the positive there, or negative square root of 5, comma 2. So I think those are our 3 points. We have, I'll circle these for us. We have 0, negative 3, square root of 5, 2, and negative square root of 5, 2. So if I were to kind of plot those points on my graph here, I would guess that this is 0, negative 3 is going to be at the bottom, and then my square root of 5, 2 would probably be this one. My negative square root of 5, 2 would probably be that one. So that's the 3 points. Again, a little bit trickier as those aren't integers with those square roots of 5. but you can still use substitution to find the answer to those systems of nonlinear equations. All right, guys, hopefully that helped. And until next time, keep doing your math homework fast and accurately.